Hello and welcome to this Functional Skills Maths Level 1 and Level 2 training video on ratios. The learning outcomes for this video are to define a ratio and a proportion and carry out basic ratio calculations. The linked learning to previous lessons are that ratios and proportions are very similar to fractions of amounts. So in previous lessons, we could have done a question where Harry and Lara share £100 and Harry gets 1/4 of this amount. How much does each person get? So to work out Harry's, using our knowledge on fractions of amount, it would be 1/4 of the £100. And we know that we need to do this, so it's 100 divided by 4, which is 25. So Harry would get £25. Now, to find out what Lara gets, we could do it in a different way, and we could say, well, there was £100, Harry's getting 25, therefore Lara gets £75. So the question is, what are ratios and proportions? Well, a ratio is a relationship between two numbers, and a lot of you have seen the ratios written like this, where you share something out in the ratio of 2 to 1, and these are what we call parts. A proportion is actually a fraction, and this is where we have 1/4 of 100. So it's a fraction of an amount, essentially. So let's concentrate on ratios initially. Now, a ratio compares a part with a part. So 2 to every 3 or 2 for every 3 is a way we would describe a ratio in words. So for every 2 students that are going to pass the Functional Skills Maths exam, 3 will fail. And we would write our ratio pass to fail 2 to 3. And this is what we call our strap line and how we set up our ratio. And from this, we can do all of our ratio calculations. Now, the top tip at the bottom says, whichever way it's written, so the way it's written here is the way you write this strap line. So for every 2 students that pass, so pass is 2, then 3 will fail. Fail is 3. And you write it the way round that it's written. Now, a proportion is slightly different in so much as a proportion compares a part to the whole thing. So 2 out of 5 students will pass the exam. So what we get really with a proportion is that 2 out of 5, we get the numerator and we get the denominator. So 2 out of 5 will pass. Now remember when we covered fractions, so what's not being said is that the number that will fail, and remember what we did when we were trying to find 1 with a fraction in our fractions lesson, there must be 3/5 left that fail. So if 2/5 pass, 3/5 fail. So with a proportion, we just mention one of our 2 things, which is to pass, and the fraction that represents it. What we're not saying is the other thing we're looking at and the fraction that represents that. So essentially, a ratio compares parts with parts. So these are essentially fractions, the numerators of a fraction. So for every 2 people that pass, 3 people will fail. As a proportion, we write one of those 2 fractions down, so 2/5 will pass. What we don't tell you is that 3/5 is fail, and that's up to you to work out. So it's saying the same thing, but in a different way. So ratios and proportions can be linked together if you think of them as fractions. So if we had a ratio of 3 to 2, let's just say red paint and white paint because we want to mix it and make pink paint, then our ratio would be 3 to 2. 3 parts red and 2 parts white, giving us 5 parts in total. Now, if we were talking about a proportion, we would call it a fraction. We would say when you're mixing red and white paint, you need 3/5 of red. So can you see that a ratio is actually a fraction where we're not actually writing the denominator down? All we have for a ratio are the numerators. When we're talking about proportions, we're talking about one of our two fractions where you need to work out the other fraction. And we covered that in our fractions lesson. Okay, let's have a look at our two basic ratio calculations. The first one is what we call ratio totals questions. And this is where you're given the total of something and you have to divide it between our two ratios. Now, Pete bakes a very nice cake. And in order to bake my cake, I need 3 parts of flour to 4 parts of sugar. So my ratio, as it's written there, is 3 to 4. Now, what I'm going to give you is a total. So my total cake must weigh 350 grams. How much of each ingredient do we need to use? So the way to answer any ratio question really is to set up your strap line. So as it's written there, put the letters down for flour and sugar so you don't get them mixed up. And then as it's written, 3 parts of flour to 4 parts of sugar. And this has set up what we call our strap line. Now, the cake must weigh 350 grams. So the 350 grams isn't all flour, it's not all sugar, it's a total. So we'll put the total over here. Now, when you deal with total ratios, you need to know the total number of your parts. So the total number of parts is 7. Now, what we need to work out is something called the scale. And we need the scale to tell us what we're going to do with each of these two sides. So, to find out our scale, you divide your total by your total number of parts. So 350 divided by 7 is 50. So each part is worth 50 grams. Go back to your strap line of your ratio and multiply each side by 50. So 50 times 3 is 150 and 50 times 4 is 200. So in order to make my cake weigh 350 grams, I need 150 grams of flour and 200 grams of sugar. Have a go at this one and see how you get on. Don't forget to pause the video before I give you the answer. Okay, now this is a Pete's top tip, and this is how you set up a ratio, and getting good at ratios is quite important. In our class, there are 3 male students for every 2 female students. So let's set up our strap line. We've got males and we've got females, and there are 3 males, so the 3 goes under there, and to every 2 females. Now notice we wrote it down as it's written in the question. There are 20 students altogether. So the 20 isn't all males or females, it's a totals question, so we put it over here. And when you deal with totals questions, you need to know the total number of parts, which is 3 plus 2, giving us 5 parts. To find out our scale, divide your total number of students by the total number of parts, and it tells us what 1 part is worth. This is our scale. Go back to your ratio strap line that you set up and multiply each side by the scale. So 4 times 3 is 12 and 2 times 4 is 8. So to answer the question, how many male students are there? Under male we have 12. So there are 12 male students. Here's another totals question for you to have a go at. In a bag of mixed nuts, there are 2 walnuts, so walnuts, there are 2. For every 3 cashews, cashews, there are 3. So our ratio is 2 to 3, walnuts to cashews, as it's written up here. If there are 15 nuts in total, so the 15 isn't all walnuts or all cashews, it's over here as a total, we need to work out the total number of parts, which is 5. To find our scale, divide our total by the total number of parts, giving us 3 as our scale. Go back to your strapline for your ratio and multiply each side by 3. So 2 times 3 is 6, 3 times 3 is 9. So to answer our question, how many walnuts are there? Under walnuts, we've got 6. Did you follow that and get that correct? Okay, here's an exam style question for you to have a go at, where some jam is made from 1 part sugar to 3 parts fruit. So we have sugar and fruit. The ratio 1 to 3 as it's written. Sugar, fruit. And then we've got 500 grams of jam to be made. So the total 500 isn't all sugar or fruit, it's a total. And when we have total questions, we need our total number of parts. So 500 divided by 4 is 125. This is our scale. And we take our scale and we go back and we multiply each side of our ratio by that scale. Now, the other type of ratio you need to become familiar with, and this is probably the most important of the two calculations, is what we call a parts ratio. So instead of getting the total, I'm going to give you one of the two parts and you put that value under the part to find your scale. Let me show you. So Pete's Fantastic Cake has 3 parts flour to 4 parts sugar. So we've got flour to sugar, and it's 3 parts flour to 4 parts sugar. Now this time I'm going to give you one of the two ingredients. So I'm telling you that I've only got 80 grams of sugar. So how much flour do I need to use? And let's just assume I've got as much flour as I need. So the 80 grams is sugar. It goes under the S side of our ratio. That's why we put the S there, so we know where to put this 80. So under our sugar, we put the 80. Now, in order to find our scale this time, we have to ask ourselves, how did I get from 4 to 80? Now, to work out your scale, in other words, the number that's multiplied 4 to give you 80, is you take this bottom number, 80, and you divide it by the top number, 4, and it tells you I've multiplied by 20. Now, this is easy to see in some ratios you'll get, but others, when we get complicated decimals and conversions, you might need to work this out properly using a calculator. So the bottom number divided by the top number. 80 divided by 4 tells me I've multiplied 4 by 20 to give me 80. So our scale is 20. So if I multiply one side by 20, I need to multiply the other side by 20. So that gives us 60 grams of flour. So if I use 80 grams of sugar, then I've got to use 60 grams of flour. And this is Pete's top tip. This is something you will use at least 2 or 3 times in your exam. We use it for converting measures. We use it for converting money. It's used on map scales. It's used almost everywhere within the various topic areas. Okay, so here's a question for you to have a go at and see if you can come up with the correct answer. So to make grey paint, we mix black paint and white paint in the ratio of 5 to 3. So the way it's written, black is first, so that's the 5, and then the white paint is the 3. So from this first line, we set up our strap line. How much black paint is needed if we have 6 litres of white? So I'm giving you something very specific. It's not a total, it's something that relates to our two parts. And I'm giving you the white. 6 litres of white. So in order to work out our scale, how did I get from 3 to 6? Divide 6 by 3, and it tells me I've multiplied it by 2. So what I do to one side, I do to the other with a ratio. So 5 times 2 gives me 10. So I need 10 litres of black paint to go with my 6 litres of white paint. Here are a couple more for you to have a go at. So the ratio of men to women at a football match is 11 to 4. So set up your strap line, men to women, 11 to 4. How many men were there if there were 2,000 women? So the 2,000 relates to women. It's not a total for the game. It applies to the women. So work out your scale by dividing your bottom number by your top number, and it tells you that your scale is 500. I've multiplied this by 500. What I do to one side, I do to the other, and when I multiply 11 by 500, I end up with 5,500 men. And if you wanted to, you could answer a question saying, what was the total crowd? Well, add the 2,000 to the 5,500, and you have 7,500 for your total crowd. To answer this question specifically, how many men were there? There were 5,500 men. Another ratios parts question for you to try. Mary is the presenter of a weekly radio show. She plays 5 new songs for every 2 old songs. So our ratio is new to old, 5 new for every 2 old. Last week she played 15 new songs. So the 15 applies to the new. So how did I get from 5 to 15? To work out my scale, divide the bottom number by the top, and it tells me I've multiplied 5 by 3 to give me 15. What I do to one side, I do to the other, and it tells me she played 6 old songs. Now it's asking how many songs did she play altogether. So she played 15 new plus the 6 old gives us 21 songs in total. A couple of practice exam questions on ratio parts type questions. See if you can get the correct answers. Orange cordial is diluted by adding 4 parts of water and 1 part of cordial. So I have water and cordial, 4 parts to 1. So that's our strap line. That's our starting point. How much water should be added if there's 25 milliliters of cordial? So the 25 is cordial. The 25 lives specifically under the cordial. That's why I've labeled this part C. How did I get from 1 to 25? I've multiplied it by 25. And what I do to one side, I do to the other. So 4 times 25 is 100. So how much water should be added? 100 milliliters of water. Here's another practice exam question for you to have a go at. A jelly is made from 1 part gelatin and 4 parts of water. So we've got gelatin and we've got water, 1 part of gelatin to 4 parts of water. Our strap line is set up. If we use 320 grams of water, so the 320 is very specifically water, so it goes under the water, we calculate our scale. So 320 divided by 4, which gives us 80. So I've multiplied 4 by 80, so my scale of 80, to get 320. What I do to one side, I do to the other. So I need 80 grams of gelatin. Now, the question is how much total jelly is made. So we add the two together, 80 plus 320 equals 400 grams of jelly. Now, ratios, much like fractions, can be written in what we call simplest form. So very similar to fractions. So if we had an image like we've got here and we wanted to know the ratio of red fish to green fish, so write it down as the question writes it in the same order, red to green. Count the number of red. There are 12 red fish and 8 green fish. Now, sometimes, very occasionally, you'll get a question that asks you to simplify a ratio. So all you need to do, like a fraction, is see what number divides into both of those. So I can see I can divide both sides by 2. So it becomes 6 to 4. And again, I can see I can divide both sides by 2. And I get 3 to 2. So the ratio of red fish to green fish in its simplest form is 3 to 2. Now, here's one for you to have a go at. In a recipe to make cake, you need 200 grams of flour, 100 grams of sugar, and 50 grams of butter. Now, this is the first time you've seen a 3-part ratio, and there's nothing different. You have flour, you have sugar, and you have butter, and you have 200 grams, 100 grams, and 50 grams. So instead of having 2 parts in our ratio, we have 3 parts in our ratio. And they want us to write it down in its simplest form. So I can see all 3 of these numbers divide by 10. So it becomes 20, 10, and 5. I can also see that the 3 numbers I've got now all divide by 5. So I end up with 4 to 2 to 1. So the ratio of flour to sugar to butter in its simplest form is 4 to 2 to 1. Just to show you there's absolutely no difference on 2-part, 3-part, 4-part, 5-part ratios, let's just do a refresher on something we've done previously but with a 3-part ratio. So we have £9,100 and we want to split it in the ratio of 2 to 4 to 7. Now we've got no headers because we don't know who's going to get the 2, 4 or 7 parts. So we'll just write the ratio down. Now it's a totals question because the £9,000 is to be split amongst all of them. So the £9,100 lives over here and we need to find out our total number of parts, which is 13. So divide 9,100 by 13 and it gives us our scale of 700 per part. Go back and multiply each one of these by 700 and you get £1,400 for the first part, £2,800 for the second part, and then £4,900 for the third part. So ratios can have 2 parts, 3 parts, 4 parts, and so on. One of the most popular places you use more than 2 parts in a ratio is usually for recipes. Now, believe it or not, mixing concrete requires a recipe. So have a go at this question. Rick needs to make concrete for his new driveway. To make 6 kilograms of concrete, you need cement, sand, and gravel, and he uses 1 to 2 to 3 to get those ingredients to get 6 kilograms. Now, how much of each ingredient does he need to make 21 kilograms of concrete? Well, this is a totals question. Because we're making the concrete, the 21 is a total. So take the 21 and divide it by the total number of parts, which is 6. Now this time our scale is 3.5. So we need to go back to our ratio and multiply each of our parts by 3.5. So he needs 3.5 kilograms of cement, he needs 7 kilograms of sand, and he needs 10.5 kilograms of gravel. Can you see how we got that? Now, so far, we've concentrated on ratios and totals and parts ratios. Proportions are the same as ratios, but instead of seeing the two numerators to a fraction which give us our parts, a proportion will give you a fraction, just like we did in fractions of an amount. So a proportion is a question like this: 2/5 of 250 pounds. So when we did our fractions section to the course, we did this. We turned our fraction of an amount into this calculation. And on the non-calculator paper, we showed you that we could do this quite easily. And it became 2 times 50, which is 100. So the proportion, 2/5 of 250 pounds, is 100 pounds. Now this aligns itself to a totals type ratio question, where you have the total amount here of 250 pounds. You're dividing it by the total number of parts, the denominator, to give us our scale of 50, and then we're multiplying it by one of our two numerators. In other words, one of our two parts to our ratio. So 2 times 50 gives us 100. Now, sometimes you'll get a proportions question that is better off written out as a ratio. So Jane gives me 24 pounds. So there's me and there's Jane. And now Jane says that what she's giving me is 2/3 of her cash. So she's giving me two parts, then she must have one part herself, because when we do our ratio, this little bit is invisible. So as a ratio, me and Jane, I get two parts, she gets one part. Even though it's written as a proportion here, we're turning our proportion into a ratio. So let's just remove this to avoid any confusion. So I'm getting two parts, therefore there must be one part left for Jane. Now the 24 pounds is mine, it goes under me, so the 24 pounds lives here. To find our scale, how do we get from 2 to 24? Divide the 24 by 2 and it tells you our scale of 12. What you do to one side, you do to the other, so Jane got 12 pounds. So how much did she have to start with? Well, if I had 24 and she had 12, we add the two together, she had 36 pounds to start with. And this aligns itself to a parts ratio. You're turning your proportion into a strap line because you understand the numerator is the parts for me, and you can work out what's left for Jane. Have a go at this question and see if you can use the ratio method to calculate this proportion style question. So there are 12,000 home fans at a football game. So the 12,000 are going to go under the home part of our ratio. If this, in other words, the home fans, is 3/5 of our total, so the home fans is 3/5, what do we think there were for away fans? Well, if we've got 3 parts of our 5 parts here, then the away fans must be the remaining 2 parts. So don't forget, this is invisibly 3/5, this is 2/5. So using our proportion of 3/5 for our home fans, we've worked out there are 2/5 for our away fans. Now, the 12,000 home fans have to go under the home side of our ratio. so the 12,000 goes here. We need to find our scale. How did I get from 3 to 12,000? Divide 12,000 by the 3 and you get 4,000 as your scale. What you do to one side, you do to the other, leaving 8,000 away fans. How many fans in total were there? Then add the two together. 12,000 plus 8,000 means a crowd of 20,000 fans. Now finally, I'd just like to mention the fact that what we've just done with proportions is essentially what we will be doing when we come to do pie charts. So covering it now while we're talking about proportions will make it easier and quicker when we come on to data later in the course. Now, a pie chart divides something up into a proportion. So one part of our pie is our proportion. And now this proportion will be given to you as a fraction of an amount if you're doing level 1. And if you're doing level 2, your proportion could be a fraction, a percentage, or the number of degrees that make up our circle. Now, all you need to remember when you come to pie charts is that this fraction or percentage or degree is a proportion of an amount. And we've just seen how to calculate proportion questions. Let's do a quick example just to finish this section off. Mrs. Pie has asked her maths class to vote for their favourite flavour of pie. You can tell it's an American question because of the way they spelt flavour and the flavours of some of these pies. The choices she gave them were apple, cherry, pumpkin and chocolate cream. Now, there are 30 students who chose for each flavour, so the whole pie is worth 30 students. Now, in order to work out how many students like each of the types of pie, all you have to do is turn each of the types into a proportion of an amount. So if 50% liked apple pie, then it's 50 over 100 times 30. And that tells you there were 15 students. And all you need to do is the same for each of the other parts. So to calculate the chocolate, it's 30 out of 100 times 30, which is 9 students. And for cherry pie, it's our 10% rule. So 10% of 30 is 3 for both cherry and pumpkin. So what I'm trying to describe here is that a pie chart really is just a proportion. And that completes our learning outcomes. They were to define a ratio and a proportion and carry out basic ratio calculations. Our buzzwords for this lesson are ratio. Now, a ratio is a relationship between two numbers. So Pete's wonderful cake is made up of flour and sugar in the ratio of 3 to 2. And we called this setting up of the ratio a strapline, and we wrote it down as the question was written. We said that there were two main types of ratio questions, and they were totals questions, where the cake had to weigh 100 grams, so we divide it by the total number of parts, and we find our scale of 20. We multiply each of our parts by our scale to give us 60 grams of flour and 40 grams of sugar. Then we had our parts ratio. Now our parts ratio, when we had our 3 to 2 of flour to sugar, gave us a certain amount of one of these ingredients. So if I had 90 grams of flour, the 90 would have to live under the flour because it's one of our parts. To find our scale this time, divide our total 90 by what we've got 3 to get our scale of 30 this time. What you do to one side, you do to the other to find out that if I have 90 grams of flour, I need 60 grams of sugar. Don't forget, you can work out the total weight of the cake by adding the two together to get 150 grams. A proportion is essentially a fraction. So 2/5 is a proportion. So 2/5 of 160 would tell us to divide this by this, and it gives us 32. 2 times 32 is 64. So a proportion is a fraction of an amount. Do not forget the relationship between a ratio and a proportion. If you have a ratio of 3 to 2, they are the numerators for a fraction where the total of the parts is your denominator. So 3 to 2 means 3/5 to 2/5, but we just don't put the denominators in. And a proportion is one of the two parts. So if I tell you one of the two proportions is 2/5, then the other proportion, or what's left, must be 3/5. I hope you've enjoyed this video. If you have any questions or want more practice on what we've covered, then please don't hesitate to contact your tutor.